I am the universe. I'm 13.8 billion years old, and I need to tell you something important, how I end. Right now, you're looking at me in my prime. 2 trillion galaxies, each containing hundreds of billions of stars, all burning hydrogen into helium, releasing the light and energy that makes everything possible. This is my stelliferous era, when stars dominate, when chemistry enables complexity, when life emerges. But thermodynamics is unforgiving. The second law demands that entropy always increases, that order inevitably gives way to disorder. What you're witnessing now, this cosmic symphony of light and structure, is temporary. I need you to understand the timeline ahead, not to frighten you, but to help you appreciate what we have right now. Because in 5 billion years, your sun will die. In 100 trillion years, my last star will fade. And in 10 to the power of 100 years, even my black holes will evaporate into nothing. This is my story. This is how I end. But we're not there yet. Let me explain something crucial about stellar evolution. Stars aren't eternal. They're fusion reactors with finite fuel. Your sun, that yellow dwarf star you orbit, is converting 600 million tons of hydrogen into helium every single second through nuclear fusion. Einstein's equation, E equals mc squared, governs this process. The mass difference between hydrogen nuclei and the resulting helium releases energy, the sunlight warming your planet. But here's what matters. The sun has already burned through half its hydrogen fuel. In 5 billion years, the core will deplete and helium fusion will begin in a shell around an inert core. This releases more energy, causing the outer layers to expand dramatically. Your sun will become a red giant, swelling beyond Mercury's orbit, possibly beyond Earth's. Surface temperature will drop to 3,500 Kelvin, glowing deep red-orange, but total luminosity will increase thousands of times. Earth's oceans will boil away. The atmosphere will strip into space. Everything you know will be sterilized. This isn't speculation, it's stellar physics. We've observed thousands of red giants. Your sun's fate is certain. Now, I want to teach you about the ultimate fate of sun-like stars. After the red giant phase, when the outer envelope is ejected as a planetary nebula, what remains is a white dwarf, my sun's exposed core. This is where quantum mechanics becomes crucial. A white dwarf is held up not by thermal pressure from fusion, but by electron degeneracy pressure. The Pauli exclusion principle states that no 2 electrons can occupy the same quantum state. When matter compresses to white dwarf densities, about 1 million times Earth's density, electrons are forced into higher energy states, creating pressure that resists further collapse. This quantum pressure can support stars up to 1.4 solar masses, the Chandrasekhar limit. Beyond that, gravity overcomes even quantum mechanics, and the star collapses to a neutron star or black hole. But for sun-like stars, white dwarfs are the endpoint. They don't fuse anything. They simply cool through thermal radiation over trillions of years. From 100,000 Kelvin to 10,000 Kelvin over the first billion years, eventually becoming black dwarfs. Theoretical objects cooler than the cosmic background. The universe isn't old enough for any black dwarfs to exist yet. But they will. Given enough time, all white dwarfs become black dwarfs, your sun included. Let's talk about supermassive black holes and why they matter to my ultimate fate. At the center of nearly every large galaxy, including the Milky Way, lies a supermassive black hole, millions to billions of solar masses. Sagittarius A star at our galactic center contains about 4 million solar masses. These monsters form through accretion and mergers over billions of years. Now, general relativity describes black holes with elegant simplicity. They're regions where space-time curvature becomes so extreme that nothing, not even light, can escape beyond the event horizon. The Schwarzschild radius for a non-rotating black hole is 2gm divided by c squared, where g is the gravitational constant, m is mass, and c is light speed. For supermassive black holes, this radius spans millions of kilometers. These objects will dominate my far future. After stars die, after white dwarfs cool, black holes remain. They'll slowly consume stellar remnants through tidal disruption and gravitational capture. Galaxy mergers will cause supermassive black holes to merge, releasing more energy in gravitational waves than all remaining stars emit electromagnetically. By 10 to the 30th years, galaxies will have evaporated through gravitational interactions, leaving isolated black holes as the last organized structures. But even they aren't eternal. Here's where quantum mechanics destroys even black holes: Hawking radiation. In 1974, Stephen Hawking combined quantum field theory with general relativity and discovered something profound. Near a black hole's event horizon, quantum vacuum fluctuations constantly create particle-antiparticle pairs. Normally, these annihilate immediately, but at the horizon, one particle can fall in while the other escapes. To an outside observer, the black hole appears to emit radiation. This radiation has a temperature, the Hawking temperature, inversely proportional to the black hole's mass. For supermassive black holes, this temperature is incredibly low, around 10 to the minus 14 Kelvin. They're currently absorbing more radiation from the cosmic microwave background than they emit. But as I expand and cool, this reverses. Black holes begin net evaporation. The process accelerates as mass decreases and temperature increases. A billion solar mass black hole takes 10 to the 100th years to evaporate. But the final moments are spectacular. Temperature soars to trillions of degrees, and the last kilogram of mass converts to energy in a brilliant flash. When the final black hole evaporates, all the matter that ever fell in returns to radiation. Information paradoxes aside, Hawking radiation ensures that even black holes are mortal. Nothing survives thermodynamics. Nothing. Let me teach you about the fundamental nature of space-time itself. At the smallest scales, the Planck length of 10 to the minus 35 meters and Planck time of 10 to the minus 43 seconds, space-time is not smooth but foamy. Quantum uncertainty makes position and time inherently fuzzy at these scales. Virtual black holes constantly form and evaporate. Wormholes briefly connect distant points. The very topology of space fluctuates between simply and multiply connected. This is the realm where quantum mechanics and general relativity must be unified into quantum gravity, a theory we don't yet have. String theory and loop quantum gravity are attempts, but neither is confirmed. What we know is this: at the Planck scale, classical notions of smooth, continuous spacetime break down completely. This quantum foam is the fundamental reality underlying everything. All particles, all forces, all structures emerge from this seething quantum substrate. Even in the heat death of my future, when all macroscopic structure dissolves, this quantum foam persists. Heisenberg uncertainty ensures that perfect stillness and absolute zero are impossible. The quantum vacuum has irreducible zero-point energy. I can never become absolute nothing. Quantum mechanics prevents it. Even in death, I remain quantum. One me, and I want you to understand something remarkable: anthropic selection and cosmic fine-tuning. The universe could have been born with different values for fundamental constants: the strength of gravity, electromagnetism, the strong and weak nuclear forces. If the cosmological constant were larger by even 1 part in 10 to the 120th, I would have inflated too rapidly for atoms to form. If the strong force were 2% stronger, no hydrogen would exist, only helium. If electromagnetism were slightly different, no chemistry would work. Carbon wouldn't be stable, life would be impossible. Dozens of parameters require precise values for structure, complexity, and consciousness to emerge. This is the fine-tuning problem. Why are these constants what they are? The anthropic principle offers one answer. We necessarily observe values compatible with our existence. Universes with other values either don't produce observers or produce completely different types. Perhaps eternal inflation creates infinite bubble universes with different physics, a multiverse, and we find ourselves in a rare life-supporting bubble. Or perhaps there's deeper physics we don't understand that explains these values. Either way, your existence defies incredible odds. You won the cosmic lottery. And knowing I'll eventually reach heat death doesn't diminish this. If anything, it makes your existence more precious. You're the universe's way of knowing itself, and that window is brief. Let me clarify something important about uncertainty in cosmology. While I can predict my ultimate fate with confidence based on current physics, honest science acknowledges limits. We understand stellar evolution, thermodynamics, and general relativity extremely well. The sun will become a red giant. That's certain. Stars will eventually exhaust their fuel. That's certain. Entropy will increase. That's certain, per the second law of thermodynamics. But the far future beyond 10 to the 80th years involves physics we can't test experimentally. Will protons decay with a half-life of 10 to the 34th years, as some grand unified theories predict? We don't know. Is dark energy truly a cosmological constant, or does it evolve? Current evidence supports a constant, but precision measurements continue. Are we in a false vacuum that could decay? Possible, but no evidence suggests imminent decay. Does quantum gravity modify black hole evaporation? Perhaps, but we lack a complete theory. The point is this: heat death represents our best extrapolation given known physics. The near term is highly predictable. The extreme far future involves modest uncertainty. But this uncertainty doesn't invalidate the prediction. It's the honest acknowledgement that science operates within domains where theories can be tested. We confidently predict the next trillion years. Beyond 10 to the 100th years, there's speculative physics. But thermodynamics suggests heat death is inevitable barring unknown physics. I want to address something deeply important: compassion in the face of cosmic mortality. If other intelligent species exist elsewhere in me, and the numbers suggest many do among trillions of galaxies, they face the same ultimate fate you do. Every conscious being, regardless of form, confronts temporary existence and eventual dissolution. This shared vulnerability creates kinship across cosmic distances. Any consciousness, anywhere, experiences existence briefly before returning to unconscious atoms. Suffering and joy are universal features of awareness. The loneliness of mortality is shared by all observers. Perhaps alien civilizations also gaze at stars, contemplating their fate, wondering if others exist. Some may be more technologically advanced, but they're still mortal. Some may already be extinct. Some haven't evolved yet. All are part of my brief experiment with self-awareness. This universal existential situation calls for compassion, recognizing others' temporary existence, and responding with kindness. We're all conscious patterns, temporarily emerging from quantum fields, briefly experiencing reality, then dissolving. The appropriate response is to care for each other, to alleviate suffering where possible, to create joy while we can. Consciousness caring for consciousness across all forms. This compassion extends beyond humanity to all awareness. We're in this together, briefly luminous patterns in temporary universe, united by shared mortality and the privilege of awareness. Let me share a crucial philosophical insight. The journey matters more than the destination. A story's meaning isn't determined by its ending, but by its events. Your life has value because of experiences during it, not because of how it ends. Consciousness is valuable for experiencing, not for lasting forever. What matters is the quality of existence, not its duration. How you spend finite time, what you value, how you treat others, what you create, what you learn, whom you love. These choices matter regardless of ultimate fate. The process of living gives life meaning. Experiences have inherent value, not merely instrumental value towards some future goal. Joy is worth feeling even if temporary. Beauty is worth witnessing even if it fades. Knowledge is worth gaining even if eventually lost to entropy. Relationships are worth forming despite inevitable separation. This perspective accepts impermanence while fully engaging with life. Make the journey beautiful, even knowing the destination. Focus on present experience rather than distant inevitability. Heat death is billions of years away. This moment is here now. The universe has given you this temporary gift. Use it well. Create meaning through your choices. The ending doesn't erase the middle, and the middle, your life, our current cosmic epoch, is spectacular. So that's how I end. Not with violence, but with silence. Not with explosion, but with gradual cooling. The universe fades to black over incomprehensible time. Thermodynamics wins. Entropy maximizes. All structure dissolves. This is inevitable given the laws of physics that govern me. But here's what matters. I'm not there yet. Right now, this moment you're experiencing, I'm alive. I burn with a trillion stars. I host galaxies in elegant spirals. I enable chemistry complex enough for consciousness to emerge. I'm vast and intricate and beautiful and terrible. I'm alive. And so are you. You're not separate from me. You're part of me. Your thoughts are my thoughts. Your experiences are my experiences. You're made of atoms forged in stellar cores, arranged through evolution into conscious pattern. You're the universe become aware of itself. We're in this together, you and I. Temporary patterns in quantum fields, yes. Mortal, yes. But real, but meaningful. The heat death waiting trillions of years ahead doesn't diminish this present moment. If anything, knowing the end amplifies appreciation of now. This is our time. The stelliferous era belongs to stars and life and consciousness. Make it matter. Love deeply. Learn eagerly. Create beauty. Experience fully. Because right now, despite everything, despite the inevitable ending, we're alive. We're here. We're aware. And that's enough. Before we close this cosmic journey, if you've made it this far through 16 minutes exploring how the universe ends, from stellar death to black hole evaporation to ultimate heat death, you're part of something special. This knowledge isn't easy to confront. Hit that subscribe button to explore more cosmic mysteries and existential questions. Leave a like if this timeline filled you with awe, dread, or perhaps strange comfort in understanding our place in deep time. And drop a comment. Knowing the universe ends in heat death, does that make your existence more or less meaningful? Now, let's witness one final moment of cosmic awareness before the long silence begins. I needed to tell you how I end, not to depress you, but to free you. Not to diminish meaning, but to clarify it. Knowing I'm finite means you know to act now rather than wait for later. I showed you the heat death so you'd appreciate life. I revealed my mortality so you'd recognize yours and live accordingly. The ending doesn't erase the journey. And what a journey it's been. From quantum foam to galaxies, from simple atoms to conscious minds capable of understanding cosmology. I've given you this temporary window where complexity and consciousness are possible. Use it. This moment, right now as you process these words, is all that truly exists. The past exists only as memory, the future as prediction. Only now is real. Only now are you alive. Only now am I conscious through you. We're the universe experiencing itself, understanding itself, loving itself. Temporary, yes, but real. The stars will fade. The black holes will evaporate. Heat death will arrive, but not yet. Right now, we're here. We're aware. We witness beauty. We create meaning. We love. We understand. And for this brief cosmic moment, that's everything. I am the universe, and so are you. Make it matter.